Welcome to Lesson 1-2, Order of Operations and Evaluating Expressions. So here's a door prize, and you get two choices. You can either get $20 immediately, or you can get $1 the first day, and then each day for the next 5 days you get twice the previous day's amount. Oh, you'd like that, would you? All right, well, let's see who's right. So we need to understand powers. Powers is a way to represent repeated multiplication, like 2 times 2 times 2 times 2 times 2 times 2. It's multiplied 1, 2, 3, 4, 5, 6 times. So we would call that 2 to the 6th power. A power has two parts. A base, which is the big number, the number that gets multiplied over and over again, and the exponent. The exponent tells you how many times to multiply the base by itself. Together, the base and the exponent are called a power. You read 2 to the 3rd power, or 2 cubed, 5 to the 2nd, or 5 squared. Those are the only powers. The 2nd power and the 3rd power are the only powers that have special names like that. 2nd power is squared, 3rd power is cubed. You can simplify a numerical expression when you replace it with its single numerical value. For example, 2 times 8, if we simplify that, we call it 16 because it's more simple. To simplify a power, you replace it with its simplest name. So what's the simplified form of 10 to the 7th? Well, what does 10 to the 7th mean? It means 10 multiplied by itself 7 times. So 10 times 10 times 10 times 10 times 10 times 10 times 10 is going to be a 1 with 1, 2, 3, 4, 5, 6, 7 zeros after it. So that's 10 million. What about 0.2 to the 5th? What does that mean? It means 0.2 times itself 5 times. 0.2 to the 5th is 0.2 times 0.2 times 0.2 times 0.2 times 0.2. And if we were to use a calculator, 0.2 times 0.2 times 0.2, there's 3, times 0.2, there's 4, times 0.2, there's 5. It's 0.00032. So 0.2 to the 5th power simplified is 0.00032. So what's the simplified form of each one of these expressions? 3 to the 4th power means 3 times 3 times 3 times 3. And I know that 3 times 3 is 9, so these two become 9 times another 9, which is 81. 2/3 to the 3rd power, or 2/3 cubed is another way we could say that. But what does that mean? Even though there's a fraction, it doesn't change what this power means. It means the base multiplied by itself 3 times. So 2/3 times 2/3 times 2/3. And now on the top we get 2 times 2 times 2. On the bottom, 3 times 3 times 3, and that is 8 divided by 3 times 3 times 3 is 27. I know that fraction's not going to reduce because the only factors on top are 2's, the only factors on top are 3's, so nothing's going to cancel out. 0.5 cubed is 0.5 times 0.5 times 0.5. 0.5 times 0.5 times 0.5 is 0.125. 0.125. There, we simplified all three of those. So, when we're simplifying an expression, we need to do things in the right order. You might think about simplifying the expression 2 plus 3 times 5 in two ways. You might think about it like, hey, I'll just go from left to right. I'll add first. 2 plus 3 times 5. Well, 2 plus 3 is 5. And 5 times 5 is 25. But somebody else might look at that and say, well, I like multiplication. I think multiplication is awesome. So I'm going to do the multiplication part first. So 3 times 5 is 15. And then 2 plus 15 is 17. Well, who's right? Is it okay to have this get me two different answers? Not if I want math to make sense. So a long time ago, mathematicians all agreed, and there really wasn't much argument about this, but mathematicians all agreed that multiplication was more powerful than addition. So we do that first. And they came up with this order of operations. So the first thing we do is perform operations inside grouping symbols, such as parentheses and brackets, and a fraction bar is also a grouping symbol. If you have like 2 plus 3 over 5, we figure the top is one group and the bottom is another group. So we'd have to do the 2 plus 3 first. So 5 over 5, which equals 1. Okay, so first is grouping symbols. Things inside parentheses and brackets, and the top and bottom of fraction bars. Second thing we do is simplify powers. The third thing we do is we multiply and divide from left to right. So that means that if there's 2 times 3 divided by 6, we're not going to do the 3 divided by 6 first. We're going to do from left to right. 2 times 3 is 6, and then we'll divide by 6. And then we're going to add and subtract from left to right also. Now you might have seen something like this before. PEMDAS, which stands for parentheses, exponents, multiplication and division, addition and subtraction. Now, this is useful if you can remember it right, but there's more to it than just parentheses, right? There's more to the first group, the first priority than just parentheses. It's any grouping symbols. So maybe GEMDAS would be more appropriate. Although powers, maybe it'd be KAPUMDAS. But any way you remember it, it doesn't matter as long as you're doing grouping symbols first, then simplifying powers or exponents, then doing multiplication and division from left to right, and then doing addition and subtraction from left to right. Alright, so let's simplify a numerical expression. So, let's remember the order of operation. Grouping symbols first, followed by powers, then multiplication and division from left to right, and addition and subtraction from left to right also. So, grouping symbols. What's inside the grouping symbol? 6 minus 2. So what's 6 minus 2? 4. So now we got 4 to the third power divided by 2. What do I do next? Well, this says I do powers next. So 4 to the third power means 4 times 4 times 4. And 4 times 4 times 4. 4 times 4 times 4 is 64. So now we've got 64 divided by 2, and 64 divided by 2 is 32. Alright, B. Grouping symbols first. Alright, well, the only grouping symbol we have is the fraction bar. So all that means is we have to simplify the top of the fraction bar and then the bottom of the fraction bar before we divide the top divided by the bottom. Well, up in the top fraction bar, we don't have any grouping symbols inside the top, the next priority is powers. So we're going to do 2 to the 4th. Well, 2 to the 4th is 2 times 2 times 2 times 2, 4 times. So 2 times 2 times 2 times 2 is 16. So this becomes 16 minus 1 over 5. We're still simplifying the top. So 16 minus 1 is 15. And now we've got 15 divided by 5, which is 3. Alright, so shall we pause and see if you can do these on your own? When you feel like you have your answers down right, push play again, and I'll show you the solutions. Okay, for A, 5 times 7 minus 4 squared divided by 2. First we look for grouping symbols. I don't see any grouping symbols. No parentheses, no brackets, no fraction bar. So next is powers. And I do have a power. 4 squared means 4 times 4. So 4 squared is 4 times 4, which is 16, divided by 2. Alright, what do I do next? Multiplication and division from left to right. So 5 times 7 is 35, minus 16 divided by 2 is 8. And then I need to do 35 minus 8, which is 27. Alright, B, 12 minus 25 divided by 5. Okay, grouping symbols. There are no grouping symbols. Then powers. There are no powers. Then multiplication and division. No multiplication, but we've got division here. So 12 minus 25 divided by 5 is 5. Now we can do the subtraction. 12 minus 5 is 7. And C. 4 plus 3 to the 4th power over 7 minus 2. Alright, grouping symbols. I have to do the top, simplify the top, and simplify the bottom before I divide. Simplifying the top, I need to do the power first. 3 to the 4th power, we did that just a minute ago, and we got 81. So we got 4 plus 81 over 7 minus 2. Now, I have addition and subtraction, but this really kind of means division, but since it's a fraction bar, and we've got operations in the top and the bottom, the fraction bar tells us the top is grouped and the bottom is grouped. So I have to do the 4 plus 81 and the 7 minus 2 before I can evaluate this fraction bar. So 4 plus 81 is 85, and 7 minus 2 is 5, and 85 divided by 5 is 17. Okay, so when you see something like this, 4xy, with a number and some next to some variables, or just some variables next to each other, like xy squared, you treat it like that thing is in parentheses. Okay, so xy squared, you got parentheses around that whole thing. You evaluate an algebraic expression by replacing each variable with given numbers. So, for number 1, what is the value of the expression for x equals 5 and y equals 2? So we got x squared plus x minus 12 divided by y squared. So x squared is 5 squared plus x is 5 minus 12 divided by 2 squared. Okay, I got powers here. 5 squared is 25. Minus 12 divided by another power. 2 squared is 2 times itself twice, so that's 4. I did my powers. Now I can do multiplication and division. I've only got division. So 25 plus 5 minus 12 divided by 4 is 3. And now I do 25 plus 5 and then minus 3. 25 plus 5 is 30, and 30 minus 3 equals 27. Alright, so xy quantity squared. So that means in here, when you have x next to y, that means x times y. So this is going to be 5 times 2 squared divided by xy means x times y, so 5 times 2. Inside grouping symbols first. So 5 times 2 is 10. 5 times 2 is 10. Now powers. 10 squared means 10 times itself twice. So 10 times 10 is 100. And then 100 divided by 10 equals 10. 10. It's kind of a fun word to say. 10. 10. Try it. It's fun. 10. 10. I'm having a good time. I hope you are. Alright, so why don't you pause it and see if you can figure these out. Okie dokie. So, for parts A and B, so for part A, 3b minus a squared. So 3b means 3 times b. So 3 times b equals 4 minus a squared. So that's a is 3, so 3 squared. No grouping symbols. Next is powers. So 3 times 4 minus 3 squared means 3 times itself twice. 3 times 3 is 9. No more powers, so now multiplication and division. I have multiplication. 3 times 4 is 12. And now subtraction is the only thing left. 12 minus 9 is 3. Alright, for this guy, 2b squared. So 2 times b squared, b is 4, minus 7 times a, which is 3. Okay, I don't inside my parentheses there's nothing to do. All I got is just a 4 and just a 3. So nothing to do inside grouping symbols. Next is powers. I do have a power here. 4 squared means 4 times 4. So 4 times 4 is 16, minus 7 times 3. 2 times 16 is 32, and 7 times 3 is 21. And I was doing the multiplication here before I do the subtraction. And now 32 minus 21 is 11. Alright, so what is an expression for the spending money you have left after depositing 2/5 of your wages in savings? So first we need to come up with an expression for that. Next we need to evaluate the expression for weekly wages of these different amounts. Alright, so the first thing we need to do is relate this words into some kind of mathematical sentence. So our spending money is our total wages, and then we have to take away 2/5 of our wages, because the 2/5 of our wages we're putting in savings. Then we'll have left, our leftover is our spending money, which we like. Okay, so let's define a variable. Let's let W equal our wages. So we get the expression W minus 2/5 times W. the wages minus 2/5 of your wages. So we can make a table with the different values of wages. Then our process column would be our expression that we came up with. And then the output column will be our spending money, depending on how much money we make. So for 40, we're going to do, let's see, we got W minus 2/5 W. So that's 40 minus 2/5 of 40. Well, how do we do 2/5 of 40? That's what we have to do first, right? So multiplying fractions, you can consider 40 to be 40 divided by 1. And now we multiply the top times the top and bottom times the bottom. So 2 times 40 on top, 5 times 1 on the bottom, which is just 5. 2 times 40 is 80. Now we need to divide before we subtract. 80 divided by 5 is 16. And then 40 minus 16 is 24. So if we take a look at our chart here, you would just do that for each one of these. Why don't you try evaluating these expressions, basically doing the fraction multiplication part, and seeing if you get these correct answers. And then we'll take a look at number 4. Why don't you pause and start again when you're ready to see number 4. Alright, number 4 says the shipping cost for an order at an online store is 1/10 the cost of the items you order. What is an expression for the total cost of a given order? What are the total costs for orders of $43.79 blah 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 dollars? Alright, so we know that you're going to have your cost plus your shipping, which is 1/10 of your cost. So if we let C equal the cost of our items, then we get this expression C plus 1/10 of C. Alright, so let's make this table. Our cost over here, the different costs of our orders are $43, $79, $95, and $103. Then the process column is going to be C plus 1/10 of C, and then our total will be what we get when we do the process column. So for 43, it's 43 plus 1/10 of 43. Well, when you divide 43 by 10, which is what you're going to do, because you're going to do this, 43 plus 1/10 times 43 over 1, multiply 1 times 43 to get 43 on the top, 10 times 1 to get 10 on the bottom, so we're going to do 43 divided by 10. And when you do 43 divided by 10, anytime you divide by 10, all it does is move the decimal place 1 to the left. So that's 4.3. So that gives us 43 plus 4.3, which is $47.30. For 79, it's 79 plus 1/10 of 79, which is going to be 79 plus 7.9. 79 plus 7.9 is 86.9. So $86.90. For 95, it's 95 plus 1/10 of 95. 1/10 of 95 is going to be 9.5. So 95 plus 9.5 is $104.50. And then $103 order, 1/10 of 103 is going to be 10.3. So 103 plus 10.3 is going to be $113.30. So, which prize ends up being better? $20 now, or $1 the first day, then each day you get double the previous day. So, here you get $1 on the first day, plus there's going to be for the next 5 days. So 1, 2, 3, 4, 5. Each day it doubles. So 1 plus double, 1 doubled is 2. 2 doubled is 4. 4 doubled is 8. 8 doubled is 16. And 16 doubled is 32. Well, shoot, just on the last day you're getting more than $20. And in fact, this adds up to $63. And over here you only get $20. But at least you didn't have to wait. Alright, so go ahead and jump on practice 1.2 and then work on the formal write-up. And I'll see you on the interweb.